0 because that's before the experiment we're doing actually starts. That's before we start whatever we're doing, whether it's cards or coins or dice or playing craps. We start at x equals 0, and that tells us what our initial starting amount or starting number was. So when you look at your scatter plot, which you can't see yet, there. When you look at the scatter plot, did you see that guy tucked up there? That's your 186, way up there on the vertical axis. I like that. That means we start with 186, which means you might go into a casino with $186. And you can analyze how long you can expect to stay in there until you run out of money and have to leave. Does that make sense? You might be analyzing how much you want to pay for an insurance policy. This is my budget. What can I get for my buck? Or my many bucks, or my few bucks. Josh, what are you going to say? Go ahead, my friend. I don't leave you hanging anymore.
I was just going to say, well, according to this pattern, you say that we shouldn't really trust this pattern wholeheartedly because it doesn't work on our data, right?
Not perfectly.
Not perfectly.
But
because technically speaking, from what I get from this is when on the graph, on the chart,
yes,
where it says 0, 180.
186.
Yeah, doesn't that essentially say that some people already got heads before we started flipping?
Good for you. No. It means that 186 of us are going to play the game before we start flipping. We haven't, 0 flips have happened. We haven't started flipping yet. It's kind of like the race is lined up and that's the starting line. And then as soon as I go, and the one flip, now we're going. Is that fair?
Yeah, cool.
So here's what I want you guys to do for next. Take your TI, get into Y1, clear out the mess that's in there. Clear out that mess, just press clear in there. Just erase that quadratic equation, because it doesn't work anyway, does it? No. And I want you to type in the equation we just came up with, which was 186 times. Now, be careful here. We have to put 1/2 to the x power. Now, there's a couple ways you can do that. We can make 1/2 be 0.5, or we can make 1/2 be 1/2. What would you rather?
Yeah.
Have to be 1/2. Thank you for the vote. Thank you. Left parentheses. 1 divided by 2. Right parentheses. Is that fair? Now, go ahead, Ashley. Ask me that question. Or Jory, somebody's asking me something. Or Desiree.
Yeah.
You don't. I was curious to see what you guys said about here. If you said 0.5, you would need it. Because you have to have times 0.5. But since you guys went with this, you don't need to have it there. Very good, Des. Thank you. How do I put to the x power? Do I just do this? No, that's times x. Little caret. In case you've never learned this little guy before, I hope you have. He's right above the division sign. A little caret button. This is a holdover from 1980 spreadsheet technology. It makes me happy. Just like the asterisk for times is a holdover as well. It makes me happy as well. To the x power. You ready? Press graph. Ho! How well does that fit our data? Well, I'd say it fits pretty damn good.
That's right.
I'd say it fits pretty damn good. Now, some of you might be concerned. Because we had this interesting little hiccup over here at 13, right? I love that, by the way, that whole little. So let me show you something that you can use to zoom in on that. We've used Zoom 9 before. Watch this. I'm going to show you something. You tell me if you think it's useful. I'm going to do what's called Zoom box. And I'm going to draw a box around this tail. What this will do is it'll stretch the window up to only show me what I'm drawing a box around. Okay, there's our data, there's our curve. It's fitting pretty damn good, guys. Oh, Des, there you are. Boop. See, there's that 13, 1. At the very top there, I can trace over to it. Here we go. Where are we? Here comes the spider right there. Now, our model predicts that we should not have 1. We should have 0.1835. Which you can't have 0.1835 anyway. That's a fraction of a flip, correct? But that's because it's predicting not an actual number of flips, but rather an average average number of flips, which means if we were to do this experiment over and 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 over again, you're going to see a very, very small percentage of the results come up with 13. Good. Is that fair?
How did you make that box?
Oh, so zoom box.
Yeah. Or zoom
The way you do that, let me go back to zoom 9. The way you use zoom box, if you're ever interested, and I do want to come back to why I was interested in this. Suppose I wanted to see more closely what's going on right here. Go to zoom,
Got that.
press 1. Now you see how the little blinker shows up in the middle? Scooch him using your arrow keys down and over. So let's suppose you want to draw, let's say Amber, you want to draw a box around, say, this right here.
Yes.
Get that guy into one of the corners of the box you want to draw. It doesn't matter which corners, get him to one of the corners.
So not on the line.
Not on the line, just above it, because if you put it on the line, you run the risk of not seeing it.
Okay.
Put it over here, maybe. I'll put it right there. Are you close to where you want to be?
Yes.
Yeah. Press enter 1 time.
Oh, there we go.
Now, use your arrow keys to drag it to the opposite diagonal corner. You usually don't have to go down very far, but you want to go across.
And then enter again.
And then enter 1 more time, and it'll stretch that box so you can see everything.
Perfect.
Yeah, pretty slick, huh?
Yeah.
Then you can see just there. Now the problem with this is, and you can rezoom. You can rezoom and rezoom and rezoom and zoom in even closer if you want to, and you can refine your zoom. But the real reason I wanted to do that, and I wanted to zoom in is, why am I so excited about this model? Other than the fact that I get excited about math all the time. But why am I so excited about the way this model is behaving compared to the quadratic model?
It's not going to quadratic model into the negative, not predictive.
Oh, that was good. I'd forgotten about that, Christy. The quadratic model went negative, which doesn't make any sense. And then what else did it do?
Came back up.
It went back up. What does this do neither of?
The linear.
It never goes back up, and it never does what?
Down.
I wasn't thinking, it doesn't drop into the negatives, which doesn't make any sense, because you're taking a half of a half of a half of a half. You're never going negative. You're just getting smaller. Is it ever going to reach 0? Theoretically speaking, no, it can't. Even though we did, right? As we got to 14, we were at 0. But that's okay. Theoretically speaking, the averages will never get it. There's always that chance, isn't there? There's always that chance that somebody's going to take 8.2 million flips to get heads. Tails, 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 what the hell? Tails, order for pizza, tails, tails, I need a beer, tails, tails.
Kill me.
Right? You kill me, right? The idea is, there's always that chance, it just shrinks off to basically 0, realistically speaking. So here, let's finish with this. Okay, our coin flip model. Our coin flip model. We'll have to save the cards for next time. It's okay with you guys. That's okay. We'll do the cards next time, I promise. But I want to wrap this up by